Now let us see first thing, that is why the D block elements are called or said as transition elements. So first of all, uh, D and F block elements. So D and F block elements. This lesson, it's a continuous part. So I think you have studied in your first year, that is a periodic table. So in that periodic table lesson, we are going to read up with how the elements are going to be arranged, from which rule it starts, and what is the what to say concepts of it. For example, based on what we are arranging the elements. Okay, does it approved by everyone in the committee members, or what might be the trial and error method it's going on till the modern periodic table what we got. So that and all we are studied. But now in your second year syllabus, we are going to take each part of it. Okay, we are going to take up each part of it, and from that part we are dealing with the concept of element. What is the special properties? What is the special nature of the element? So same like that, S block elements or the alkaline and alkaline earth metals are known. Some special characters are not there. So for that, we are done with S block elements. SP block elements, we having a special nature. So how it will act on it, and our living element is present, that is called oxygen. So that also we studied, and how this is going to be interact with the other atom if it is supposed to be like combined with any other. So that and all we are read. So now let us see what happened with the D and F block elements. So in periodic table, as we know that we have four groups, S, P, D and F. So this is D and F block elements is like sisters. So why we are said it sisters means the continuity of the D block elements in middle F block element will come. Okay, if you see the periodic table, you can see the continuity number is not there in your D block element. For example, in the 5D series, so 57 is lanthanum, but 58 it's in the F block element. So that's why it call it as a sister blocks. That's why it's called as sister blocks. The continuity of the elements will takes place in both the D and F block elements. So now D block elements is called it as transition element, and F block element is called as inner transition elements. So D block is transition and F block is inner transition elements. So what do you mean by inner transition or transition? That is our concept, and we need to know what are the elements arranged over there, and do they have same properties like D block and F block? Do they have same properties or not? So these the things we need to read, and how it will interact with the other atom, and if we need to produce any one of the element among in the D and F block, how we can produce it, and what is the basic property of it, and how it will behave. So this and all things we need to read in this lesson. Okay. So now D block elements are the series. Okay, it's a series of fourth long periods. It started from 4th, 5th, 6th and 7th. So it is a zone of that. So if you have your periodic table, you can just see, open it up. Just take your periodic table. Call it as transition element. So why it is called as transition element? Can you give a definition? Why we are calling B block element has an transition. Transition. You can just split up the word transition element. block inner transition. What does it mean, Nikhil? Transition. The word you can split it up. Transfer, transition. Srujan, Gokul, Meghana. It is both metal and non-metal. Okay, agreed. But does it define transition? It is partially filled. You mean to say outermost orbitals are partially filled, Nikhil? Yes, Gokul giving an answer. The D-block elements are called transition elements because they exhibit transition behavior between S and P block elements. Exactly, Gokul. So it's a transferring. As I told you, the transferring methodology means to say it will carry some behavior from the S block element and it is traveling towards the P block element. So S and P, it will be acting like an intermediate between S and P block element. That's why it kept in between S and P block elements. I think you might have asked with me, so when the periodic table has been classified, it tends to classify what happened. The SPDF are continuous series, but what we did, we have just make it as a discontinuous, like your left side is S block and right side is P block and middle is D block and down A block. You might have asked me, ma'am, why they were classified like that. I think it should be like continuous. First, if it start from the left, S, then next P, next D, next F, it should be in that sequence. But no, because of the specified behavior, because of this behavior, we are keeping the elements like this. So I think by arrangement only you got to know that transition series or D block elements is an element which will show the behavior of S block and P block also. Okay, so that's why we call it as transition elements. Is it okay? Okay, fine. Then next, write down the definition for the D block elements. It is an element tomorrow you have a test, right? Define as element whose atoms in the ground state. This is standard definition. I'll explain it. What do you mean by this? Ground state or in any one of its oxidation states have partially filled B subshells. So the first definition, first line of the statement says that it's an element which the electrons are present in ground state. It means to say, if you are arranging an atom like this, okay, this is a one transition zone of element. So you can write in a circle way or you can write like this also. So these are energy levels. So what they were saying, the electrons are present more in ground state. Ground state means to say that is very nearer by the center of the metal. So it means to say the size of the atom may reduce because of the force of attraction they held. For example, suppose if the electrons are moving outside the orbital, if it's moving far away from the center of the atom, so what it will happen? The force between the center of the atom to the outermost electron will lose, and that's why the electron might have lost from the atom. So yavaga distance middle of the atom in the outermost orbital ಗೆ ಡಿಸ್ಟೆನ್ಸ್ ಜಾಸ್ತಿ ಆಗುತ್ತೋ, ಸೊ ಡಿಸ್ಟೆನ್ಸ್ ಜಾಸ್ತಿ ಆದಂಗೆ ದ ಫೋರ್ಸ್ ಆಫ್ ಅಟ್ರಾಕ್ಷನ್ ಮಿಡ್ ಆಫ್ ದ ಆಟಮ್ ಇಂದ ಔಟರ್ ಮೋಸ್ಟ್ ಸೋರ್ಸ್ ಆಫ್ ಡಿಸ್ಟೆನ್ಸ್ ಏನಾಗಿದೆ ಜಾಸ್ತಿ ಆದಂಗೆ ಇಟ್ ಕ್ಯಾನ್ ಲಾಸ್ ದ ಎಲೆಕ್ಟ್ರಾನ್ ಫೋರ್ಸ್ ಆಫ್ ಅಟ್ರಾಕ್ಷನ್ ಲೆಸ್ ಆದಂಗೆ ಎಲೆಕ್ಟ್ರಾನ್ ಕ್ಯಾನ್ ಮೂವ್ ಔಟ್ ಆಫ್ ದ ಆಟಮ್. So because of that, your d block element, what it will do, it will just make an element arrangement inside of it. ಅದಕ್ಕೆ ಏನ್ ಮಾಡುತ್ತೆ, ಔಟ್ಮೋಸ್ಟ್ ಆರ್ಬಿಟಲ್ ಗಳಿಗೆ ಕಳಿಸೋ ಬದಲು ಇಟ್ ವಿಲ್ ಮೇಕ್ ಒಳಗಡೆನೆ ಇನ್ನರ್ ಶೆಲ್ಸ್ ಅಲ್ಲೇ ಇಟ್ಕೊಳ್ಳಕ್ಕೆ ಟ್ರೈ ಮಾಡುತ್ತೆ. ಫಾರ್ ಎಕ್ಸಾಂಪಲ್ ಇದಕ್ಕೊಂದು ಎಕ್ಸಾಂಪಲ್ ಕೊಡ್ಬೇಕಂತ ಹೇಳಿದ್ರೆ, it's just an nourishing of a woman with a man. ಸೊ ಒಂದು ಹುಡುಗ ಅಥವಾ ಹುಡುಗಿನ ಬೆಳೆಸೋ ರೀತಿಲಿ ಹೋಗುತ್ತೆ. ಸೊ ಹೇಗೆ ಅಂತ ಹೇಳಿದ್ರೆ, if a boy need to go out for either it may be for study or it may be for job, the parents, those who are take care of them, they can readily leave them. Like for example, yes, you should settle down in your life, so you can go and you can do. But the thing in case of girls, if they want to earn more, if they need to go out, they are not allowing. If you don't work also, no need to worry, please stay in home, like that they used to say. And they are saying like, you need to travel, you can travel. If this seems to be long journey, then also they are saying you can travel, but you need to stay out. So this is the kind of thing. Instead of moving the electron towards outside, the electron force or the mid force of the atom is attracting the electron towards inside. Because of that, the electrons are arranging in the ground state level. Ground state level means inner orbital state levels. There's the first line says. And the second line, what they're saying, in any one of these oxidation states have partially filled d block shells. It means to say the arrangement of an electron is not completely filled to the valence electron. Andre electron galu complete agi fill aagta illa, it will goes to d block, and the d block elements having 5 subshells, that 5 subshells are partially filled. Partially filled means to say 10 electrons is not there. Either it may be 8 or it may be 9 or it may be 7 or it may be 5, 6, whatever. But it should not completely fill. It should partially fill. That is called as incomplete filling of an orbital. So that is the behavior of d block element. Because of this nature, because of the partially arrangement. So partially arrangement andre enagutte, the orbital, the outermost orbital will contain unpaired electron. It means to say single electron. So if the presence of single electron is there, the atom or an element should be more active. If it is supposed to be more active, it will react with other component or it will give color nature. This is the very important concept in your d block elements. So because of the unpaired electron present in the outermost orbital, that is d subshell is partially filled. Because of that, your d block and f block elements are tends to give its own color. Okay, so that is very important point. I think you might have recognized with flame test. While doing the flame test, we used to do with what to say, cadmium, titanium. Idradella color kodutte. Barium, it will give green color. So like that. So transition elements basically it have its own coloring nature. Which point I need to repeat, Gokul? Like why it's giving color? That point. Because of the outermost unpaired electron, because of the outermost unpaired electron, it seems to be like a single paired electron, that is partially filled d block elements. So because of the presence of unpaired electron, the transition elements are giving colored nature. Colored nature. You might have asked me, ma'am, in F block, in P block and S block also, in some elements we can see unpaired electrons. For example, carbon having 4 unpaired, nitrogen having 3 unpaired, but still it doesn't give color. Why? So, as according to your statement, you are saying because of the presence of unpaired electrons, it will give color. Now I have a question. In p block elements also I have it, but it doesn't give color. Why? Mohammed, why it's so? Srijit? Pratik? Tell me why it is so? Monisha? Why you all are stop texting with me? Only 4 are texting like Gokul, Nikhil, Sujan, Meghana. Kiran, you also stop talking with me. Harshita. My question is to say that. So as according to my statement only, I told you that because of the presence of unpaired electrons in the outermost orbital, it will give colored nature, right? So because of the unpaired electron present in the outermost orbital, it will give colored nature. But now, p block elements also have some unpaired electron. S block elements also have some unpaired electron. But why only D block and F block will give colored nature? Carbon, that carbon powder, it will give black color. But if you see an carbon component like carbon dioxide or carbon monoxide, it doesn't having this color. There is charcoal component only having a black nickel, not in carbon. Oxidation state, having oxidation state of 4 carbon because of D block and d orbital and d orbital. Okay, d and f orbital. You can do one thing. We have sodium level 1s2, 2s2, 2p6, 3s1. Okay. Take down. Okay, xenon. Take down xenon 18. So xenon 18 elements are there. So D block will come, but it doesn't give color. The color is due to valence electron exist in D existation. Almost correct. So okay, I'll tell you. So what I'm saying is, if the electrons are unpaired in their outermost orbital, that's why it will give color. That electron should be in the D block series. It means to say, if the unpaired electron is present, it means to say only unpaired electron is not giving, but it should present in D series, and that it should excite, it should jump from the orbital. It means to say your electron should be in the ground state. So these are all the specifying characteristics of D block elements. That's why your D elements and F elements are giving color. So because of this reason, we can say that is because of the unpaired electrons that is present in D block element, and that is to partially filled and that having the characteristics of arranging of element in the ground state level due to the excitation of electron. Yes, Rujan. D and F block elements having valence electron in present, and it has last three incompletely filled electrons. So in both D and F block elements, last three incomplete shells. Okay. So yes, Yavaga, if the electrons are supposed to be vacant means to say it should be one electron should not be there. If the subshells is like that, empty subshells, or it should be partially filled. So that will be more active when you are compared with completely filled. You can give the example of noble gases. Noble gases are said it as inert gases, or it doesn't work at all. It doesn't interact with any other atom. Why it is so? Because it is just like a filled tummy. It means to say it have everything, it consumes everything, so you are not interrupting anything with the others. So that's why same like that our 18th group elements is completely filled till the valence orbital. So that's why it doesn't want to make it saturate, or it doesn't want to make it stable by adding or by removing any of its electron. That's why it seems to be inert gas. It doesn't work with any other elements. Okay, got it? So you have zinc, cadmium, mercury, +2. So see, all are in the state of +2 oxidation state. Okay, so you have two types of question here. Why D block elements are called as transition elements? If they'll ask you like that, you need to say it's an intermediate compound between your S and P block elements, that it will be it having some characteristics of S block, and it have some characteristics of P block element also. So it means to say that it will show some characters, means the ionic property of S block and covalent property of P block elements. So that's why it is called as transition elements. Okay, fine. Next, let us see the position in the periodic table. So position means to say how these electrons are arranged, where it will arrange. So in your entire P block series, it is present in between. Okay, it's present in between S and P block. Okay, it is present in between S and P block elements. And